Hello everyone. We are going to have Amit Sharma currently. He's from the Netherlands and he will have the lecture API Security in the World of Microservices.
Hello everybody. So my name is Amit. I come from Netherlands, but born and brought up in India. You can make out from the color of my skin. I don't want to be racist, but then I just thought maybe I make a comment of that. This is my first time in the Balkans, in the Balkans conference in Serbia, and I really liked it. The sun is really hot and scorching, but I thought, okay, I come from India, what about it? But no, it is very, very hot here. I can feel it, though in India it's also very hot, but it's more hot. Anyways, so thank you very much for coming to the talk. So yesterday I was in the dinner with all the other people as well, and after coming back from the dinner, I thought that I need to revamp my slides because there was so much content. And then I thought, okay, a lot of people know a lot of things, and I don't want to start my presentations like, okay, hey, I will show you how a cross-site scripting works. Like, okay, there is a pop-up everywhere, or maybe an SQL injection works. Then I thought about it a lot, and after looking at the title of my slides, like API security in the world of microservices, I thought about one of the drawbacks from security perspectives in microservices, and that was undiscovered APIs. And that's exactly what I was searching for. Like, okay, what should I put next on the slide which is a little different than regular things? So I thought I'll put a perspective on this and give you a thought about how to look at APIs when you're actually dealing with microservices. So let's start with that. Then the question is, why should we look at APIs differently after all? Because in the world of internet, there are a lot of things which changed, and a lot of things you can see in the conference as well. Go to the retro place and you see that how we have evolved significantly. Same was with the applications as well. So there were different kind of applications earlier. Now the applications are totally different. There is a whole lot of evolution that has happened. And most of it happened drastically over the past few years. And that's where the importance of security also enhanced significantly because a lot of people were using internet than before. Before the APIs came into picture, there were different kind of applications, but basically there were APIs as well at the back end. So what is an API? It's basically how one component of an application interacts with the other component for exchange of information. Because computers are not intelligent, thank you, but I think they are going to change in the future. But today we need to tell the computer on what needs to be done. And that is exactly why APIs were developed, right? So they need to say, hey, I want a data, or maybe I want a soda, go bring a soda for me. But initially, when there were three-tier-based application architectures, like a client, something in the middle, and something at the database, and we used to interact with them, it was basically calling them via some kind of HTTP methods. So HTTP is the protocol which is used to interact with these kind of applications, and you get something back in the format of an HTML. But when you look at APIs, and if you call an API, then you get a lot of raw data out of it. Now, I would like to stop here for a moment and give a thought. Do you think we should give a different thought from security perspective for APIs, or we should treat them equally in the room? No? Everybody thinks that it should be treated as same as a web applications? Okay, we will see that. No? Yeah. Now, one of the most important aspects that we were looking at the application surface was what can go wrong when we are actually interacting with the applications. And when we were interacting with APIs, the thought was, how can we get more data out of it? Now, it might be a possibility that there is a vulnerability in an application but getting it to an exploit is just another ball game, wherein you want some data. But if you talk about APIs and you're able to get hold of that one guy, which is doing nothing but just the job it was built for, but you're just abusing the functionality of the APIs that the definition was written against. So let's move forward on why we should be talking about these things. So what I did was I pulled up some data from different research papers done by some companies in the same area. And what we saw was that a lot of attacks which are happening today are based on APIs. Now, when you're interacting with APIs, there are two different ways to do this. One is, of course, interacting with it from a perspective of an authenticated user, which means, hey, I'm allowed to get the data I am asking for. And then there is a perspective of an API in which we say, hey, you have to give me data irrespective of whether I am supposed to have that data or not. And then the research said that, okay, like 78% of them were authenticated attacks. Like, okay, first somebody was authenticated to the APIs and then they did the attack. And then the 22% was unauthenticated attacks, which is you're not allowed to do things, then you still do things. And how are these attacks happening? And you'll be surprised to know that 41% of them are because there are some kind of vulnerabilities which are actually existing as a part of the API developments. And then you see a little bit more numbers like 40%, which is the second strongest number, which is authentication bypass, which means you have did everything right, but you did not define the authentication mechanism for that API right, which means yeah, like if you are user A and you are allowed to get the data of user A, and from attacker's perspective, I just change the user A to user B, and then I have the user B's data as well, while still being authenticated as user A. So the definitions of authentication mechanisms for these APIs became very, very crucial while we are actually accessing data against this. Some more data about why it is really important. Every day there are new attacks which are happening because there are so many different kind of APIs that are available. As and when we are getting more and more connected, we are getting more and more data. You know, people who are using mobiles today are exponentially higher than a decade before. And people who are using apps on those mobiles, like 5 years back, your mobile was having like 50 apps. And now it will pretty much have more than 100, 150 apps. That means we are actually interacting with these applications to have information, gather data, and that's how we interact with different kind of APIs at the back end to get this information to the customers. Now there is a whole different ball game at the back end on how we can play around with data and make sure that you're scrolling enough throughout your web app. But today we will do this differently. Now, why all of these different vulnerabilities are popping up every now and then? Any answers?
Well, more and more APIs means more and more inexperienced developers creating them, more shift.
Yeah, that is one of them for sure, yes. And I'm going to touch that topic as well on why it is becoming more and more difficult from developers' perspective. But from this guy's perspective, it is, oops. From this guy's perspective, it is very easy. The only thing he needs to do is he needs to identify that one API that is going to give him the data that he wants. So the best way to do it is, hey, go to an application and then just start asking questions to the applications and send some requests that the applications was not expecting. Like if you want to say, hey, abc.com/v1, which is version 1 of the API, and then / you write something, and then the response will be, hey, I don't know what something is, but now you know that there is nothing called as something which is existing on the server. And that's how you enumerate all of the different kind of API calls that you can do to make sure on what is exactly the application's functionality that you want to exploit. We call it as behavioral analysis of the application, and this is one of the major chunks where we actually look into the APIs or applications from behaviors perspective on who is accessing what, not only from when we want to attack it, but also when we want to solve issues. So let's say if there is an SQL injection in an application, and it is basically doing some kind of changes as a part of your API, and then making sure all the data is dumped. Now, at the back end, when you are a developer or a person who is actually looking into the logs or doing some kind of monitoring as a part of your SOC, you can actually say, hey, this particular API was supposed to take 0.01 milliseconds, but suddenly there is a request which is going haywire and taking more than 5 seconds. That means it is not doing things that it is built for, which is a change in behavior of the application. And that is a red flag. So more and more behavioral analysis is done on the APIs nowadays to make sure that we are able to identify any kind of anomaly in the behavior of the APIs to see how we can defend it and how we can also attack it if we are wearing the black hat on that aspect. Now, we saw some data from the industry perspective, but I also want to bring your attention on how the developers or DevOps team also look into this aspect as well. So when there was a research done by another company, it actually asked a lot of different people on when are the security controls implemented as a part of your development cycle, or if you want to protect your APIs. And surprisingly, the numbers were very nice if I'm looking from an attacker's perspective, but if I was the one who was responsible to keep the API safe, it is a bummer. 32% of the controls was implemented at production. Why? Because nobody cares. I can actually say, hey, I have implemented a WAF, which is going to catch all things related to OWASP top 10, and yeah, let's have a coffee. The next aspect was how many of the APIs are documented, which was also very surprising, that 41% says that only 50% of the APIs were documented. Now, documentation of API is altogether a very, very huge topic, and why it is important. Now, in the world of information and data, you want your application to be used as many, with how many people you want. For example, if you're developing an application, you say that, okay, I want a 5 million user base. That means you need to define your APIs in such a way that other people can grab data from, which means you have to document those APIs and also open it to the public so that they can use it effectively. Now, how many people are doing that? 50%, according to this research. And this is also very important from an attacker's perspective. So if you're planning to actually attack an API, the best way to do it is grab the definition of that API. Now, there is a specification document which is called as Open API specification. Earlier, it was also called as Swagger format. So the best way is just grab that, look through it, how the definition of that particular API is. Now, once you know about it, you're actually having an upper hand, because now you also know the use cases that you need to try, which are not documented as a part of the API. And that's how I was actually thinking about yesterday when I was defining this, this presentation, that I was traveling with some of my new friends from the airport. And then suddenly we stopped at a red light. But the driver was very, very smart, and he saw a lane which was really empty on the right-hand side, which was like not the lane of the traffic, and he just bypassed the traffic and came away. And I was like, wow, this was the undiscovered API. So this was, everybody was knowing that it exists, but the guy knew on how to use it and take advantage of it. Because it was not documented as a part of the traffic rules, let's put it that way. So while all of these things were going on, the world really changed, and there were a lot of different things that happened as a part of our software architectures or application development or processes, methodologies, or whatever you want to say. And there were discussions around whether we should be using something called as monoliths and something called as microservices. Anybody who knows these words? Okay. It's just a way to say, see some hands, right? It always looks nice, right? So let's talk about monoliths a little bit. So monoliths look something like this, wherein there is somebody who is trying to access data, and then there is a business logic layer, and that business logic layer is the one which defines whether it wants to go to the definition or do the task that it is asked for. As the world changed, as I said, things also changed, and they thought that, okay, this is not very efficient with all the new kind of technologies like cloud natives, Kubernetes, and all those kind of things which came into picture. And then there was a new thing which was born, which is called as microservices. Now, microservices were alternatively treated as APIs, but no, microservices can use APIs, but are not APIs. Microservices are just microservice architecture, which means if you have a monolith application, I have the capability to basically break down it into different components so that different people can use different components at the will they want to. Now, let's say if you're using a portal in which somebody is actually asking for invoices, but the other guy is asking for just doing an order of food or a delivery of the food. So there are different components within the applications which are defined according to the functionality that they are supposed to do, and then there is somebody in the between who actually manages the traffic towards these different players within the game. Now, one thing, as I said, is really, really important to understand that microservices can have APIs, but an API is not a microservice. API is just any call from one application to the other application to just grab some data. So these microservices become really, really important when it comes to APIs, because now you have a lot of different APIs. Earlier, you were having like a couple of calls which were happening between the monolith applications, but now you can actually define different kind of APIs calling different kind of functionality to be served by different kind of users. It can be from mobile, it can be from computers, it can be just knock at the door and, hey, bring me a soda kind of thing, but it's also having a lot of different kind of calls. The other important aspect for microservices was that it is very, very distributed architecture. So you have the capability to define on how do you want to build, what kind of technologies do you want to use, and where do you want to deploy it. Which means if you are within an organization developing a particular application and you like Rust more than Python, you have the capability to do that. Now, somebody wants to deploy it on Azure, they don't like AWS, or maybe somebody's a Google fan, they want to deploy it on GCP. Yes, you can do that without any kind of problem and impacting the business functionality of the application. But now the problem of governance come into picture, that whether the organization wants everybody to deploy their code everywhere, or do they want a very streamlined process around it. But again, that's a different topic altogether. Now, I also wanted to show a little insight on how the monolith applications were regarded as really, really complex. And the reason of microservices coming into picture, like I can say one of the reasons was removing the complexity. But unfortunately, that did not happen. Microservices are regarded as much more complex in terms of deploying and utilizing it. But from an end user perspective, it is very easy. From the timing perspective, it is super amazing. But when you look at it, it looks something like this, if you want to just break down an application into different kind of microservices. So you have different components there, like a web application, then you have a load balancer, then there is a backend, then you have different kind of services which are defined to do certain tasks. Now, this might also look very nice to you because, yeah, it is good. But when you see the traffic which is going on among these different microservices, it looks something like this, which is a lot of calls to different kind of services happening at one particular point of time, which means different API calls happening between different services. So the attack surface of the APIs grew humongously when the industry changed from monolith to microservices as well. So now you should know about how to write APIs in not Rust and Python, but also the languages. And that means you need to also secure all those APIs in a different manner. Same goes in terms of deployment as well. If you are deploying in AWS, then it's a whole together different ball game. And if you're deploying in Azure, then maybe a different set of services are used and a different strategy is required on how to secure those. So that brings me to the point on what are the security challenges when you're actually talking about microservices. So let's think together. One of the major things is more services to tackle with, which was very evident from the diagram I showed you, right? There are more services, more API calls. That means there is something more that we need to tackle. It is more complex because now we have a lot of things. And as we already saw that only 50% of that is documented, we need to also identify on what is not documented. And things which are unknown are more dangerous than things that are known. A very good example is our well-gone virus that we recently experienced. That, okay, there was a new zero-day vulnerability that came to the world, and nobody was knowing how to fix it. And then we tried different things to try to fix it. We succeeded for a part of it, but there was a lot of, or huge losses as well that we have to take care of. So it is always good to know something which exists rather than not knowing what exists. So yes, the world is more complex now. More things to look at. Now, one is, of course, these calls which are happening for the APIs, but there are different components that also get added as a part of microservices architecture. For example, API gateway. It was actually designed to make things easy, but then it is really important for you to make sure that everything is working as expected from security perspective as a part of API gateway as well. So it's very similar to you actually have a building and you said that, okay, it has to have 5 exits and all those 5 exits need to be secured so that I know who is coming in and who is going out. But you just said it and you did not put the locks. So anybody can come in and anybody can go out. So it is really important that you put the controls in a very estimated manner as a part of API gateway. Then there is another monster in the microservices architecture, which is called as service mesh, which is more of at the network infrastructure layer in which how do we interact with different services. It was also supposed to solve a problem, and it does to a very significant level. But from security perspective, you need to exactly know on what's going on to make sure that everything works perfectly for the functionality. So yes, one of the major security challenges is it is distributed. So if you're using multiple infrastructure and you need to secure all those individual infrastructure things, then you need to scale up to see how you can do that. So this is one of the biggest challenges in today's world as well. The one is the data management, because it is spread across, there are different places, whether you're using volume or, I don't know. Yeah, it is also a very big beast to actually tame. Third one is segmentation and isolation, because you're having different microservices as a part of the whole architecture itself. So it is really important that you're segmenting those architecture components in a proper way, so that not only the network but the data is also managed properly right from one service to the other while providing information to a particular service. The third or fourth one and the most important one is providing identity and access. So yes, if you want to use a particular API, it is important to provide an identity to that API, which means what that API is going to do. And the second one is handling that access, which is actually going to tell you whether you're allowed to do certain stuff with that API or not. So yes, management of identity and access is worth a thought when you're defining security policies as a part of your microservices architecture. One of the other major challenges are that all the changes that are happening in this microservice world are very, very rapid and very, very regular, because every time there are new requirements, yeah, DevOps is there in place for a reason, because you can do things fast, you can deploy fast, and the technology landscape is totally changing very significantly as well. If you look at the CNCF dashboard, the icons are becoming more and more small, because there is always a new technology that pops up which is solving a problem, which means there is a new thing that you need to learn, and then there is a new thing that you need to learn from security perspective. So yes, so one is of course being a security officer, but also a security engineer. That means you need to know how things work, so that exactly you have the capability to basically tell that how we can stop a particular attack as well. And the last one, and the most tedious one, the APIs, which is the gateway to your applications. So any kind of application that you develop, irrespective of whether it's monolith or microservices or SOA, all of these things can be interacted with APIs. So it's really, really important that you're giving thought to the APIs that you're actually building as a part of this. Now, I also wanted to show you a little bit about how an attack will look like. So I grabbed this from the Kubernetes page in the morning. And this is how a particular attack happens as a part of the microservices architecture as well. So it is as trivial as it happens for any kind of web applications. So people who think that, okay, there are different kind of API problems that we need to solve, no. Yes, but you also need to solve issues that are existent with your applications, like an SQL injection is still valid for an API, a cross-site scripting is still valid for an API, but there is a lot of other things, like OWASP came with a new top 10, which is actually talking about a lot of different stuff with respect to APIs, but it is just a subset of the wider picture. Ultimately, you are still going to need to check all of those things that you already knew for the web applications as well. Now in this case, you see that there is an API which is being called for a regular user, like, okay, Tom is calling Tom, and there is data about Tom. And then the malicious client is basically putting something on the parameter, which is actually giving him an SQL injection. But there are a lot other steps that gets involved in this now. So there is a service task, there is a data store, and then there is a service which makes an irregular request, which is really, really important for you to understand. And there is where the behavioral opinions about that particular API comes into picture. So if you're doing an SQL injection attack on a microservices architecture, and suddenly your Kubernetes cluster is spinning up more and more pods, then it is something that you need to be really worrying about. If there is a change in latency, yes, it is important for you to know, because there might be a possibility that somebody is using the functionality right, but we are not protecting it right. So it is worth a thought when you're actually looking into those stuff as well. Which brings me to the topic of API security of OWASP Top 10 as well. So this is one of the places that is really, yeah, I should say a plethora of information that you can actually take advantage of. And initially, my talk was actually about explaining those individual topics, and then I thought, why? Because it is already available, and I had to change the whole presentation to do something different. So yes, these are all different categories of API vulnerabilities. So there was in 2019, and as you see that there is a new one which came up in 2023, and there were reasons for that, because more and more people were using APIs, and we were seeing more and more application level, API level attacks happening. And it was not only done by traditional web application based attacks like an XXC or a directory traversal, but also something related to, let's say, security misconfigurations or improper inventory management. This is a good one, because if you're not documenting a particular API as a part of your Open API specification, that means according to you it doesn't exist. But if an attacker gets hold of it, you will never know that you're getting attacked, because he has all the information from the API that you're anyways not monitoring as a part of your SOC programs. So it is really important to understand all those individually defined API endpoints and then document it right as well, so that you can take clear actions on whether you should do something about it or not. If you're testing those APIs as a part of your microservices architecture, these are some of the approaches that might be useful. One is discovering of endpoints, which we have been talking about quite a lot. And then going through your open API documentations very regularly as a part of probably every commit that you make towards your repository. It is a good idea to go through this documentation as well and see whether all the different kind of components attached to an API are properly documented, at least what you want to document, but take a conscious decision about it. Then parameter tampering and command injection has been there for quite a while, not only in terms of APIs, but also for web applications, which is a good thing to also check for your APIs as well. API fuzzing is a very, very nice and always a successful testing technique. So what you can do is just pick up the API and start fuzzing it with different kind of things. It might be different kind of HTTP verbs, methods, or different kind of endpoints, and then just sit back and relax and let it do the thing. And that actually gives you a way of how you can actually go further within the application to attack it more. And then, of course, behavioral analysis. This is also a success for all the time from attackers' perspective as well. So usually when we do, let's say, a testing program for a microservices-based architecture, the first thing from black box perspective is to identify all the different hops that my request is making. So if you're actually making a request to a particular service, which is a front-end service, then you need to actually see on how much time it is taking to come back and what kind of data it is producing. And then you change different kind of identities within the request as well. And then also see if it is taking more time or less time. And if it is taking more time, it is actually a good way to start exploring in that area. And I have pretty much got success pretty much all the time when we have followed the approach of latencies and behaviors of those APIs when you don't find any cross-site scriptings. Then I think any kind of slides are unfinished without mentioning some best practices. So I also thought to mention this as well. So some of them is, of course, a security by obscurity. The other one is using robust credential masking, awareness training, rate limiting, and leakage of third-party poor data retentions and all those things. But the most important aspect here is whenever you are actually developing your APIs, and you're looking at it from security perspective, you should concentrate on different pillars of security for the APIs as well, which is one of them is authentication. So how are you getting authenticated to those APIs, and are you doing it right? Are the different roles defined properly? Then you can take a decision on whether you want to use JWT or maybe some other token of your own name. Then you have to see if you're getting authenticated, how is the data being exchanged between these APIs? That is where the second pillar comes into picture, that if somebody is authenticated, what kind of data exchanges happens when this particular functionality is being done by the APIs. Then the third one is looking at the network layer as well. So what are you doing to see if everything is going on in the right direction with respect to the network interactions between these APIs. And then you start from there and go to different places. By places I mean is to see how are the APIs interacting, behaving, are we configuring the load balancers right, or take a decision whether you want a load balancer or an API gateway, and then see how you can define the functionalities between API gateways and a service mesh, whose responsibility is to do what. And if all of these different teams, unfortunately there are different teams doing these different things. And if these teams are not talking to each other, then it is also a very big challenge on how you're going to solve a particular problem. Because it might be that you are trying to secure your load balancer and API gateways, and the other team is trying to secure their service mesh, but ultimately the functionality is gone. And then there is some kind of misconfigurations that are happening, which is overlooked during these kind of conversations. With that, I would like to say thank you. And I'm open for any questions that you might have. I hope it was useful, and it was a little different than showing how Burp Suite works and a cross-site scripting can be popped up.
Do we maybe have some questions from the public?
I was just maybe wondering if you know the statistic, how many of these attacks are actually malicious and how many are just for fun?
This is a very good question. I do not have the statistics, but all of these were malicious attacks. The one that I showed as a part of the API security.io, let me name them as well. But whether it was really demanding something, those are pretty much unpublished things. So nobody wants to say, hey, I got attacked and I paid $1 million. So those are pretty much not available for public information. So these all are as a part of responsible disclosure programs. That's how we know it. Of course, they are given some kind of bounty that they have identified these kind of issues. But if it is a very targeted attack, yeah, there is no statistics, at least in the real world. But they are available, and I can tell you certain things about it, maybe not on camera.
Hi, thank you for the presentation.
Thank you.
I was wondering, many microservices nowadays also communicate between each other, right? Not always via HTTPS or anything like that,
yep.
But they use RabbitMQ and such. Do you see any potential threats while communicating in between those services?
That's a very good question, and I actually pondered about this yesterday as well, on whether I should be talking about message queues and other things like gRPC or GraphQL. And certainly all of the things that I mentioned today holds for all those as well. The only thing is those are just different ways of communication. The biggest advantage in the messages is it carries a little less weightage than, let's say, HTTP post request. So the attackers needs to be much more advanced to understand on how they can craft a particular exploit within that amount of data so that they can take advantage of it. We are seeing a lot of GraphQL based attacks every now and then. And we are seeing more because not a lot of people know how to exactly use these securely. There are certain companies which actually use it very efficiently and then they market it very nicely, and then you think, okay, there is a new cool technology, I want to learn it and I want to do something about it. And then a year later, you know everything about the documentation, but you have not written a single line of code. And when you start writing it, you just mess up. So yes, yeah, it has happened for a lot of different things like Kubernetes, containers, and all the new technologies have the same kind of challenges. So yes, the answer is all of these technologies are equally vulnerable to the things that we talked about today.
Okay, I think that's it, and thank you for the presentation.
Thank you. Thank you very much for having me, and I really like the hospitality of Novi Sad, so thank you.